Today on Xenodilodon, do you remember when hard drives used a platter that was 14 inches in diameter? Because I don't, and that's not even the biggest. However, I do have fond memories of the Microdrive, which used a platter that was only 1 inch in diameter. But that's not the smallest. That record goes to Toshiba for manufacturing a hard drive with a platter size of only 0.85 inches, and in this video, I'll be dissecting one of them. Like with any ethical operation, the first step is, of course, you put the patient to sleep. So we're going to start with that. Alright, Toshiba MK4001MTD, I'm going to have to ask you to count back from 01010. Excellent. Alright, we're good to go. So the first thing I'm going to do is I'm going to take off the control board on the bottom. That's held on by 4 screws, and I'm going to use a small tri-wing bit for this. And we'll see how that looks. Now my ultimate goal for this video is to take apart this hard drive, get some really good video and pictures, so that way other people don't have to take apart their 0.85 inch hard drive. I know I'm going to end up destroying this one, but in the end I do hope that I can get it put back together for aesthetic purposes, at least. I hope to remove the hard drive platter, and I hope to also remove the read-write head, and hopefully butterfly those two heads apart and get some good microscope pictures of the actual read-write heads themselves. We have a little insulating piece of plastic here, and the control board. It's all SMD components, so it makes tracing out the connections very difficult. As far as figuring out what pins do, looks to be a little pin header here for the read-write arm, and the connections for the motors. Oh, it looks like each coil gets its own individual set of wires. Probably a little 3-phase motor on the inside. We'll figure that out once the lid is open. And take pictures of that board later on. That board is very thin. This is where I now ventured out the unknown waters. A lot of the pictures that have these taken apart, they're not very good pictures, and I'm not exactly sure how the platter is affixed to the hard drive spindle, but we'll get to that once this is open. So it looks like there's 3 more screws on the top. And then around the outside there is a little sealing tape. So I've already started that, so I can undo that with the gloves on. Grab the proper tool, and here goes to the point of no return. think the cover can come off now. Oh yeah. Wow, that is absolutely tiny. So it looks like there's going to be another screw for the read-write head on the bottom. Yep. And then on the top, as I said, the platter, it looks to be like it's almost held in by a clip. So what I'm going to try to do is insert something on two sides of those clips and see if I can pull up that middle to free the platter. Looks like the magnet might be loose, so the magnet might just come right out. Let's see if it does. Oh no, that is actually screwed in, it looks like. Interesting. Wonder how that comes apart. I'm going to take some pictures of this. All right. Let's see about moving the hard drive platter now. I don't think that's coming off. Maybe I'll try again later on in the video, but where's where we're at now? I'm gonna look at removing the magnet assembly and the read-write arm. Maybe that'll be a little bit easier to take apart. It's certainly hard to tell what's holding that magnetic assembly on. I think it's this screw here in the back. I'm gonna undo that. See if that'll come apart now. Sure enough. So there's one of the neodymium magnets there. And it looks like there's only one magnet in the hard drive. Put that aside. And now to remove the board here and pull out the read-write arms. is absolutely tiny. So here on the bottom, this little bolt, and it's going to hold this whole assembly together. So I'm going to remove that bolt and hopefully slide the bearing out, and that'll give me the ability to spread those apart and put that under the microscope and get a good look at that. Get a spacer here after the bolt. I'll flip that over, that way dust doesn't get on it. More dust. And yep, the bearing assembly will come right out then. There's going to be another spacer in between the two heads. Just have to be mindful of that. And there's the bearing. Let's see if I can get these apart. Now they're on that little butterfly right there. They're on that little ribbon. That's what I'm trying to butterfly apart. Looks to be like there's a little bit of adhesive holding that on. Oh, here we go. Those are the little read-write heads. I'm gonna put these under the microscope. That way you get a better look at that. And after I put this under microscope, I'm going to see if I can finally get that platter removed so we can look at the motor assembly underneath the platter. Let's take a look at the read-write arm assembly underneath the microscope. Over here is the electromagnetic coil, which is responsible for moving the heads along the surface of the platter. And this electromagnetic coil interacts with the permanent magnet on the inside of the hard drive. The exact position of the heads is determined by the polarity and the modulation of the electricity going into the coil. Here we can see the conductors that go up to the read-write heads themselves, and the suspension that holds the read-write heads. You can see there are 4 little conductors inside of a ribbon cable. And at the tip of the suspension arm, we can see the read-write heads themselves. Now, these are small read-write heads, but they're not much bigger or smaller than the read-write heads in current hard drives. Keep in mind this is a 4 gigabit hard drive, so if you were to scale this up, these read-write heads would be pretty big. However, for the time, it's pretty impressive. Let's get a closer view on that. not all too much going on with the read-write heads themselves. Basically, it's a pair of coils and a piece of ferromagnetic material. But it's still pretty cool. Time to give removing the hard drive platter another go. After taking a look at it a little bit more, I think it might be the outer aluminum ring. That is what I should be removing, so I'll go ahead and try to carefully remove that without damaging the hard drive platter. Although I don't see much luck in doing that. We'll see what I can manage. Yeah, that's just not coming apart. One more try. I think I've done it. I don't know where that piece went. Oh, here it is. It's not in its original shape anymore. That's okay. It can be bent back. Success. Oh yeah. That is a tiny little platter. A little spacer ring on the top. Actually get a measurement on it. Let's see how big this is. Oh, it's actually smaller. That's smaller than 8.5 inches. They lied to us. Wait, maybe not. Never mind. It is exactly 8.5 inches. Cool. Let's clean that up a little bit. There we go. That's a tiny platter. Let's compare it with the 1-inch platter. Quite a noticeable size difference. It's cool. Glad I got that off. We're going to take a look at the motor assembly. And there's a little shield around there. Let's see if I can pull that shield up and off. And there's a noisy car with another motor. Anyway, looks like a 3-phase motor for sure. So it looks like it has 4 connections going onto it. And on the other side, we can see how the wires actually connect up. So there's actually 2 things that these contacts go to. The first thing is these 4 connections here. So each coil gets 1 wire, and then the other ends of the coils are joined together for a common connection. And then got these 2 connections here, which lead up through here and are connected to this little swing arm, it looks like. I think that detects how fast the hard drive is going, or if there's enough speed to let the heads unlock. Like a safety reason. So here we have the electromagnetic coils, and they're in sets of 3, so it looks like 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, 9. And maybe that's another barrier. Is that nope, that's part of the spindle. So you'll see a little bit of black material inside of there, and that's a magnet that has multiple poles on it. And what happens is these coils will get a different electrical input at different times, and that'll move the spindle around in circles. Now for the hard part. Trying to get this all back together. Let's see if I can do it. It'll be interesting. Well, there goes aesthetics. That's okay. They make more. It's a worthwhile endeavor, but my attempt has been halted. With the dissection now out of the way, let's talk a little bit more about dead technology, which this little hard drive definitely falls underneath the category of. Back in 2004, when this hard drive was first manufactured, having 4 gigabits of storage on a 0.85-inch platter was really impressive. However, at one point in time, having a couple megabits on a 14-inch platter was equally as impressive. But this technology got superseded by advancements in solid-state storage, like the microSD card, which is now up to 1 terabyte. And if you take a look at the size comparison, we could probably fit about 16 terabytes of storage in the same volume that this little hard drive would take up. This isn't the first time technology has killed off other technology. The smartwatch has killed off the mechanical watch. LCD screen has killed off the mini CRT tube used as a viewfinder. And advancements in direct diode laser technology has killed off the miniature OPSL. But I still find these little hard drives really fascinating, so I found a bit of information on the web about it. I'd like to go over that. I'll link this first page in the description below, and this goes over when the hard drive was first announced by Toshiba, and this is published in January of 2004. So here's a website that talks about the Toshiba MK4001MTD, and I found this interesting because a lot of web pages only talk about the 2 models, the MK4001MTD, the 4 gigabit version, and the MK8003MTD, which is the 8 gigabit version. It's not really important, but I'll link this web page as well as the other ones down below in the description in order. There are 2 devices that I know of that have the 0.85-inch hard drive in them. The first one is the Nokia N91 smartphone, and there's a great video by Janus Cycle who shows how the hard drive is put in the phone and how it connects to what looks to be a multimedia card port inside of the phone. However, it's not a multimedia card port, and I'll talk a little bit more about this as well. I'll also list his video as well down below in the description. And the Colwyn iAudio 6, which when you read the user's manual, it talks about the storage on the inside being a 0.85 inch 4 gigabit hard drive. And I believe that that uses the same ZIF connector as this hard drive. Now I've done a little bit of research in trying to figure out how to run this little hard drive, and the first web page that I found was on Tom's Hardware. And it talks about the interface either being ATA 100 or SDIO. And it says that inside of some of the devices it has the Tokyo Electron TE4000 external card reader control chip inside of there. However, I can't find any information on that. I did, however, find this chip, the SDIO 101A, and it seems to be a chip that it could possibly work with this hard drive. Another useful website that I found was on this Russian forum, and it talks a little bit about the 4 gigabit hard drive found in the Nokia N91. Most importantly, I found this wiring diagram here, which goes into a little bit of detail about the control chip that could have possibly been used, as well as the rest of the wiring for controlling the power going to the hard drive. However, on this diagram, it doesn't look like it directly corresponds to the ZIF pinout on the hard drive that I have. Lower on the page, I found this picture, and this allowed me to trace out some of the connections on this pad that connects to the multimedia card pad on the motherboard of the Nokia N91 motherboard. And I looked at the three largest connectors, which I assume are the positive in the middle and the two tied grounds. So on here, the tied grounds are 5 and 2, and number 4 would be the positive. So that gave me a good indication of what the wiring on this hard drive might be. Here's another page that I looked at, and this page gave me information about the multimedia card pinout. And one of the things that I noticed was that pin 2 and pin 5 are command and clock. However, if I go back to the Russian forum, we can see that pin 2 and pin 5 are COM and ground. So the pinout is not exactly identical to the multimedia card, which makes this whole process a little bit more interesting. Despite all the information that I found on the internet and making a pair of wiring diagrams myself, I still have yet to get my 0.85 inch hard drive to work, and my pinouts might be inaccurate or incomplete, but they still might help out some others. The closest that I've gotten to getting mine to work is using one of these generic card reader boards, and I've soldered wires onto the multimedia card, plus pins here that lead up to a little ZIF connector on the front. If you're trying this yourself, I also want to point out that in the card reader slot, there's a couple of contacts that act like switches. One is to initiate the card slot, and the other one is for the read-write protect. I'm going to go ahead and hook this up to my laptop, and we'll see a removable disk icon pop up. And if I press these contacts down, you'll see nothing happens. I'm going to connect up the hard drive now to the little ZIF connector, and we'll see that the icon does change. So this tells me that the power, command, and clock are probably correct. However, in some regards, I have no idea what I'm doing, and the chipset might not be capable of reading this hard drive. So I'm hoping that somebody has some answers as to how to get these things to run. Now I took some other pictures as well. Firstly, because the hard drive was at this point completely broken, I took pictures of the little assembly that I thought was a sensor for detecting the platter speed, and it turns out to be a solenoid that unlocks the heads and allows them to travel on the disk. And I also completely took apart the spindle and spindle bearing assembly for the hard drive platter, as well as the little bearing assembly that slides into the read-write heads. That's about all I have for this topic. I hope you enjoyed the pictures that are coming up, and as always, stay tuned for more.